Section 1.4, the trigonometric functions. Definition of the trigonometric functions. On this slide, you're going to be given very important information that you're going to be using throughout the course. Follow along. It says if xy is any point other than the origin on the terminal side of an angle alpha in standard position, and r is equal to the square root of x squared plus y squared, then this is how we're going to be defining sine of alpha is the y value over the r, and here's where the r comes from, which is basically the radius if you look at this picture. Cosine of alpha is equal to the x value of the point over the r. Tangent is the y value of the point over the x value. And notice there's a relationship between sine of alpha and cosecant of alpha, namely it's just the reciprocal of this ratio. So cosecant of alpha is the r over the y. The secant of alpha, again notice the reciprocal, is the radius or the r over the x value. And the cotangent of the alpha is the x value over the y value, and again reciprocal. And we're given that there's no denominator, there's no zero in the denominator, otherwise we have problems. Again, I cannot emphasize how important this slide is. And just another point, notice that the angle doesn't necessarily have to be an acute angle. Let's go on to the next slide. It says find the exact values of sine, cosine, tangent, cosecant, secant, cotangent, where alpha is an angle in standard position whose terminal side contains the given point. If you want, you can graph this point on the coordinate plane. I'm just not going to do that. I'm just going to be using the definitions that you saw on the previous slide. So first I'm going to be finding r, and I use the formula on the previous slide. In class I can clarify where that formula comes from. So we get radical 5 for r. So sine of alpha is equal to the y value over the x value. Here's the y value, here's the radius or the r, which is 2 over radical 5. And then at this point we're going to have to rationalize the denominator. This is something that you saw in the earlier course, mainly algebra. So this is how you rationalize. You multiply top and bottom by radical 5, and you end up with this, which is 2 radical 5 over 5. Now let's go ahead and find cosine of alpha, which is just the x value over the r, the radius. So I have x value, radius. This is what I get. You rationalize just like sine of alpha, and you end up with the following. Now let's do a tangent of alpha, which is just the y value over the x value. So we're looking at 2 over negative 1, which is equal to negative 2. Now, before I show you cosecant of alpha, let's make it official. These are what we call the reciprocal identities. Cosecant of alpha is equal to 1 over sine of alpha. Secant of alpha is equal to 1 over cosine of alpha. And cotangent of alpha is equal to 1 over tangent of alpha. So if I want to find sine of alpha, all I need to do is work with the reciprocal identities. So cosecant of alpha is going to be the reciprocal of sine of alpha. Here's the ratio that I'm going to be working with. I don't want to work with this one. I want to work with this one, because if I get the reciprocal of this, I end up with the following. If I work with this one, I'm going to have to rationalize it again. You still get the same answer, but this is faster. Cosecant of alpha is radical 5 over 2, just the reciprocal of this. So in the same manner, secant of alpha is going to be the reciprocal of cosine. Here's cosine, and I'm going to work with this one again, not this one. So once I get the reciprocal of this ratio, I end up with negative radical 5. Tangent This one's easy. Is the reciprocal, cotangent of alpha is the reciprocal of tangent. So the reciprocal tangent, the reciprocal of 2 over -1 is -1/2. Let's go on to the next slide. Okay, trigonometric functions, reference angle of 45 degrees. Just like on the second slide, we were using the variable alpha to represent an angle. Now we're going to be looking at a specific degree measurement of 45 degrees instead of just alpha. So if I want to look at the following 3 trigonometric functions, sine of the angle 45. Here's my angle. Here's my angle of 45 degrees in standard position with the given radius of radical 2. I'm able to generate the following coordinate value, and I will get more specific on how to do that in class. But at this point, all I'm going to do is I'm going to be looking at sine of this reference angle 45. And definition of sine of a reference angle is just the y value over the r. The y value is 1. The radius is radical 2. So sine of 45 is equal to 1 over radical 2. We rationalize, and we end up with radical 2 over 2. And cosine of 45, very similar to sine of 45. So reference angle 45, which is right here, in standard reference angle in standard position, is x over r, just the x value over the radius, which is 1 over radical 2. I rationalize just like sine of 45, and I end up with the same answer. So now, tangent of 45, still the same reference angle. It's just going to be the y value over the x value. And then I end up with 1. And now let's go to the next slide. Now we're going to be considering a different reference angle of 60 degrees. So now if I have a reference angle of 60 degrees and radius 2, it gives me the following ordered pair, 1 radical 3. And again, in class, I'll clarify where this is coming from. And basically, it is coming from the slide that you saw not so long ago, the 30-60-90 triangle and the 45-45-90 triangle. But anyway, let's continue. So I am going to be looking at sine of 60, cosine of 60, tangent of 60. So my reference angle is 60 degrees here. According to the definition of sine, it's just the y value over the r. So I end up with radical 3 over 2, and I don't have to simplify anything. I don't have a radical in the denominator, so this is my answer. I continue cosine of 60, now is going to be the x value, which is here, over the r, which is just 1/2. And then tangent of 60 is going to be the y value over the x value, and I end up with the following. Just radical 3, once I simplify. Let's go on to the next slide. Different reference angle. Now we're looking at 30 degrees. Reference angle of 30 degrees in standard position. Given that my radius is 2, I'm able to generate this ordered pair. Again in class, I'll go over that. So now, I'm going to compute sine of 30, cosine of 30, and tangent of 30. So definition of sine is just the y value over the radius, which is 1 over 2. Cosine of 30 is going to be the x value, which is, the x value over the radius. So it's radical 3 over 2. And then the last one, tangent of 30, is going to give me tangent of 30 is y over the x value, which gives me 1 over radical 3. I rationalize, and I end up with the following. This concludes the video.